Number 4, if 4.04 grams of nitrogen combined with 11.46 grams of oxygen to produce a compound with a formula mass of 108.0 AMU, what is the molecular formula of this compound? Excuse me. So, we know the mass of the actual formula. The actual formula, 108.0 AMU. So, what I'm going to do is calculate the empirical formula. Then I can calculate the formula mass of the empirical formula, compare that to this 108.0, and boom, I can figure out that molecular formula. But first, let's start. Now, I don't have to do any assuming 100 gram samples because this is already in grams. 14.01 grams of nitrogen per 1 mole of nitrogen. That'll cancel out. And then I'll have oxygen. It'll be 11.46 grams of oxygen. 15.999 grams of oxygen is 1 mole of oxygen. All right, let's see what we get here. So 4.04 divided by 14.01. I have 0.288. I want 3 significant figures there. Moles of nitrogen. Down here, 11.46 divided by 15.999. I get 0.716. Actually, I want 4 significant figures here, so I'll slap a 3 on there. Moles of oxygen. The moles of nitrogen are smaller, so I'm going to divide both mole values by 0.288. This will obviously be 1. So probably be close to 3. Divide. Oh, messed up that calculator work. 0.07163 divided by 0.288. Oh, it's 2.5. Ooh. The fun one. See, this is not close to 2 or to 3. It's right in the middle. Now, I have to have a small whole number ratio. The ratio of nitrogen to oxygen is 1 to 2.5, but it's not a whole number. So I'm just going to multiply both of them by 2. That's going to be 2 to 5. So, if the empirical formula here is N2O5, I need to calculate the mass, the formula mass of one of these units. So this is going to be 2 nitrogens plus 5 oxygens. Some calculator work up here. So 2 of those plus 5 of these is 108. Look at that. 108.0. 108.0 AMU. Which is exactly the mass of the molecule. And so that must mean that this empirical formula is the exact same thing as the molecular formula. Boom. That was easy.